During this quick introduction, you'll see how to convert the idea into an electronic device prototype. The process is divided into 10 steps. I'll do a video for each of the 10 to get a good overview and more specific information about each step. Here are the 10 steps. 1. Idea and brainstorming. 2. Specifications. 3. Part selection. 4. Pin mapping or pin assignment. 5. Schematic design. 6. PCB design and assembly. 7. Board bring up. 8. Coding. 9. Full system testing. 10. 3D design and 3D printing. Idea. All of the products around us were just an idea until someone turned the concept into a functional item. Birthing an idea is an excellent time. You can start thinking about protecting your idea by patenting it at this early stage. Just as you were open to the idea in the first place, you must remain open to the fact that there will likely be an evolution of different ideas leading to the final product. As Stanley Kubrick famously said, never say no to an idea. You never know how that idea will ignite another idea. Brainstorming. Unless you are not worried about your idea being stolen, consider having a team of several people brainstorm together. Teamwork will likely bring out more thoughts, questions, and solutions than working alone. The brainstorming period can bring a new idea to mind. It might change the original idea, or it might improve on it. So, stay open. When you are brainstorming, you should not think about any boundaries. If you think there's a box your idea has to live in, you're creating an obstacle in your mind. Instead, brainstorm with the belief that anything is possible. So let the idea grow and develop. Remember, ultimately, users of your product will give feedback about what works and what doesn't, which is the reason to move out of brainstorming and on to the next step in a short time. Specification. Now you have taken your idea and given it some shape. You need to produce the actual product. The specification is the bridge between what you want to create and how you're getting it done. The specification is the time to give all of the ideas you've been having about your product and give them more details. For instance, for an electronic product, you need to retrieve and specify is your product needs a microcontroller or FPGA, how many inputs and output you have, how the user should communicate with the device, and what about power? Is it 5 volt or 3.3 volt, or both? Is there any analog sensors, and so forth. You're creating specifications so perfect that you could hand it off to an engineer, and they'd be able to build it even without knowing your original idea. Part selection. This is where you pick your parts. The better your specification, the more straightforward creating this list will be. In this step, look at each item in your spec, retrieve the corresponding feature, find the part which, and put it in an Excel sheet. Look at it this way. If one of the items in the specification is a 485 rupees, you make 485 rupees a line in your spreadsheet. Then you pick your other building blocks. In the example of the 485 rupees, you need to find the controller with at least one UART and the 485 rupees transceiver's chip. Here's a great tip to simplify part selection. You can go to a website like DigiKey and use the component filter to find the best parts for your project. Pin mapping. These days, each microcontroller's pin can be used for different features like ADC, I2C, interrupt, etc. It would be best to map each pin to the correct peripherals before starting the schematic. For instance, if you want to connect the sensor to the ADC pins, you have many different options to connect them from ADC0 to ADC5. But if you connect something to ADC5, you cannot use the I2C feature of this controller anymore. Getting this step right, including all of your desired features, help make a more accurate schematic, which will save you the headache of having to recreate the design more than once. Schematic design. According to Wikipedia, a circuit diagram or schematic is a graphical representation of an electrical circuit. For designing the schematics, you have to have a layout software app like Eagle or Altium to connect the symbol of the real component together. Here you'll need a little knowledge of electrical engineering, EE. Many open source hardware companies like SparkFun or Adafruit suggest many circuitry designs, and they are a good source of earning EE knowledge. Any electronic component app notes and data sheets suggest some design you can use as a reference. Then, after designing your circuit, you can use some software like Proteus or Spice to simulate your design. PCB design and assembly. The printed circuit board is the foundation for all electronic systems where the components are assembled onto the board. There's some good, free layout software online such as Easy EDA, something affordable like Eagle, or up to expensive software like Altium. This step also needs a little bit of EE knowledge. When all of your schematic nets are converted to the PCB file, then all the components appear, and you need to place them in the correct position. Your EE experience comes in handy here too. Again, the positioning process is key. For instance, some bypass capacitors should be located very close to the chip VCC pin. After the placement of the components, the routing begins. First, some routing rules should be defined in the layout. Then, after the PCB is designed, the Gerber file of the PCB should be generated by the layout software and sent to the boarding house. Next, the bill of material, or BOM, should be purchased and assembled on the board. Board bring up. The board brings up the name of the process that the electronic system tested and validated to ensure all the components have a correct electrical connection together and are correctly supplied. This stage identifies any shortage of misconnection on a PCB board. This is where you may test all the voltages on a board, or flash the microcontroller with a test program to see that all the input/output and peripherals are working to ensure there's no shortage or bad connection on PCB, etc. Coding. Now you have this beautiful PCB with all the components soldered to it, and it looks stunning, unless your electronic device does not use any programmable devices like a microcontroller. It does not do anything without instruction. This is a small computer with embedded peripherals. Since the computers do not understand our language, we need to translate our instructions into the computer's language called binary file. Although most microcontrollers understand binary files, we also have other options to tell them our instructions in different languages. Assembly C or C++ are the most popular coding languages for embedded systems. Python, MicroPython, and Java can also be used since humans can decipher these languages. Converting the high-level languages into a binary file is called compiling. Assembly and C can be written in just a simple text file, using GCC for compiling IDE with a user-friendly GUI like Arduino or Platform IO. All the mentioned tools are open sources of software and free to use. It should be okay to start writing the code for a simple project, but for complicated tasks, it is better to start with the algorithm. The algorithm is based on conducting a sequence of specified actions in which these actions describe how to do the desired task. Testing. Now you write your code and need to make sure all your device systems are working perfectly. It will help put a plan together to test your device's functionality. During this testing, you may find some bugs in software or hardware which you need to fix. This could be happening by making some manual tests and step-by-step instructions to test all the features in your electronic device, or, in some cases, using some scripting languages to create an automated test. To get the most value during the testing phase, getting the specifications right and making a test case for each item is your goal. 3D design and 3D printing. The 3D design can be created using a mechanical software like SolidWorks or CAD. If you are comfortable with any 3D design software, you should use it. If you are satisfied with coding, you can use open source software like OpenSCAD. With OpenSCAD, you can make the 3D model by writing the code. After the 3D model is ready, you need to generate the STL file. Then you send the STL file to the 3D printer company to produce the model. Protolab, Xometry, or 3D Hubs are three of many 3D companies you can use. Just be aware that a lot of 3D companies outsource your model to other smaller companies or even to other individuals. So if you don't want to disclose your idea yet, maybe you need to buy a 3D printer and print it yourself. One of the cheapest and best quality 3D printers is Ender 3, which costs less than $200. Now, it's a good idea to go back to the drawing board, so to speak, and redo some of the steps. You're looking for any bugs that need to be fixed. There is always room for improvement, so don't be afraid of investing a little more time to get there. This is a quick introduction to making an electronic product in a few specific steps. I have more videos for you to dive deeper into each step. From dreaming up a product to feel the industry needs right through making it a reality ready to hit the market. Please subscribe to our channel so you won't miss any of our upcoming videos. Please leave us some feedback down in the comments section. We're also looking to improve what we have to offer. Thank you, and please stay tuned for more.